Good afternoon, morning, or evening, calculus people. This will be day 9. Guess what? Last topic, area between two curves. Take us a couple days though. So we're almost done calculus. If you're keeping up right up with me, we're only May 29th or so. So if you're keeping right up with me, you'll have a lot of time in June to do some studying and stuff as I'll get prepped up for the final. If you're a little bit behind, that's fine. If you're not there yet, but you'll be able to use that catch-up time to get caught up, no problem. Okay, so we're waiting for the board to open here. I'm going to open my preview eventually here. There we go. Board's up. Okay, let's give it a little touch. There we go. Okay, so let's get that preview going so I can see what time it is. Okay, so today we're going to be looking at day 9 or 8 or whatever day it is here. Let me look here. I always forget. All right, so we are on, let's see here. Not even in the right unit here. We are on, come on, computer so slow. We are on day 8 of this unit. All right, so day 8, unit 6 in calculus. And we're going to be looking at area between two curves, the first part. So we're going to be looking at the theory of finding area. Okay. Uses integration. And we're going to be looking at some examples. We're going to do area between two curves today, and then tomorrow, part 2, we're going to do area between two bounds, which is a little bit different. Okay, and so I'll break it into 2 parts. So there'll be 3 days in this. There'll be the area between two curves and doing some examples. Then there'll be the area with 2 curves and some bounds. Okay, or 1 curve and the axis, x-axis or something like that. And then there'll be the practice assignment, and then that'll be it for our content. Then I'll do an outline of what the quiz is for this section. Then we'll do the quiz, or the hand-in, pardon me, the quiz. We'll do the hand-in as well, and then we'll do the quiz, do it all up, and then it'll be get ready for the final. Now, the final exam, I'm going to allow a cheat sheet for the exam. That means one 8.5 by 11 where you can write anything on it relating to calculus that you want, right? Doesn't matter what you put on there as long as it's 8.5 by 11, okay? So you have to prepare for the exam and make sure you write down all your formulas that you think you're going to need, okay? So make sure you do that. I'll remind you as we keep going here. Okay, so let's go ahead and let's do this theory part for what we're going to do today. Okay, what we're going to do today is talk about area between two curves in the first part. Okay, let me just bring up my sample here that we have on my other screen. Okay, so what I'm talking about is if you're given 2 curves, something that looks like this. Let's title this first. There's our title. Okay, so let's do a little drawing here. So let's say that we have a curved, let's say we have a parabola and a line. So let's say we have parabola here, which I'll draw in blue with the vertex at 0, 0, like that. Okay, and then let's say that I have, let's say y equals x squared. Okay, and then I have a line. Let's say it just y equals 4x, make it real simple. So it'll also go through 0, 0 here. That's a straight line. Y equals 4x. We'll make it real simple. Okay, so what we're interested in is what is this area between these two curves. We've got a red curve and a blue curve here, but we want to finding this area. So what we do in calculus is we've got to do the area between this point A here where it intersects and this point here B where it intersects. And what we want to do is we want to get the area under the line and subtract the area under the curve. Okay, so we want to get the area under the line and then subtract the area under the curve, so that's what's left in between. So what it would look like is we want to get the area is going to equal the integration, okay, from the upper limit to the lower limit of f of x1, or sorry, let's not do it that way. Let's do f1 of x. That'll be better. Okay, well, let's not use a capital letter because we'll use that for integrals. So I'll keep it consistent. f1 of x minus f2 of x. Okay, and this is this one here is the upper limit or curve. So it has to be the top curve. And this is the lower limit or curve. Okay? So if you look at it, the upper limit is actually the red line because it's on top, and the lower limit is the blue parabola. Okay? So this is what we're going to do, and we're going to do this as an integral. And this is our formula. Okay, it's the integral from B to A of the upper limit minus the lower limit. Okay, so there's some steps that we've got. So first thing we have to do, let's do this example that I have here real simple, is we have to find our A and our B point. So first step, always step one, is to find the intersection points. Of the curves. Okay, so that means that they're both going to be equal to each other. So that means in our case, x squared is going to equal 4x. Okay, so that's what we're going to do. So the first thing that we do is actually some grade 10 math. So that we know that x squared equals 4x. That's where they're intersecting. So we have to solve this. So the way we can solve this is by quadratics from pre-cal. So x squared subtract 4x equals 0. Okay, now we can factor out an x. So our two intersection points, x can equal 0 or x minus 4 can equal 0. So in this case, we have x equaling 4. So that means A is 0 and B is 4 in our example. Sorry, guys. So our first step is done. Once we get the intersection points, we've got our upper limit, our where we're gonna go from 4 down to 0 of each of these. That's our integral limits. And then our upper bound of the upper curve and our lower curve is how we're going to do it with the formula. So the second step that we're going to involve now is that we are going to use the formula and input our area integral. Okay, so step 2, write out the area integral. Okay, so in our case, it's going to be area equals. Okay, so it's B to A. So B was up here, so it's 4 to 0 of our upper curve is the line 4x. Minus x squared. I put it in brackets because it could be like x squared plus 5 or something, which dx. X squared is the lower limit, right? It's the lower curve. Okay, so then we perform in step 3, we work out the integral. Work out the integral. Okay, so we're going to go ahead and do this. Okay, so it would be 4x would be 4x squared divided by 2 minus, okay, this would be x cubed over 3, okay, plus c. I'm eliminating the c's because they will cancel each other out when we're subtracting as we go from 4 to 0. Okay, and that's going to give us our area. So we work out the integral, then we plug in the limits. So that's step 4. All right, so let's go ahead and do it. Okay, so obviously the other limit's going to be, we could reduce this, sorry guys, we could reduce this to 2x squared minus x cubed over 3. So the second one is going to be minus 0, right? It's going to be something minus 0. So let's go ahead and do that. So 2 times 4 squared minus 2 cubed over 3 minus, when you plug all those in, that's going to give us a 0 over there because they're both 0, right? Okay, so if we work that out, this is going to be 16 times 2, which is 32, minus 8/3. Wait a minute. Why did I put a 2 there? It should be a 4, right? Look at my upper limit's of 4. I'm getting confused here. Sorry, guys. That's 4 cubed, not 2 cubed. So that should be 64. Okay, let's fix that up. Okay, let's do that. Minus 64. 4 times 4 is 16 times another 4 is 64 over 3. So how many would this be? This would be 96 over 3 to get 32 minus 64 over 3. So our area is going to be 32 over 3 actually, or 10 2/3 units squared. There we go. So let's summarize what we did there so we can remember what the steps are. Okay, we got the drawing. First thing we do is we find out, okay, we have our formula. It's the integral of b to the right hand limit, the right hand number or intersection point minus on the top and the left hand one on the bottom. And we're going to integrate the top curve, subtract the bottom curve. Okay, doing that. So in our case, we have to first, step one, find what those A and B intersection points are. So we take the two curves and equal them together, solve it for x, where x should have two intersection points in this case. Bang, bang. Okay, then we write out the integral formula. The area equals the integral of b a of top curve minus the lower curve dx. So that's what we did, 4 over 0. 4x minus x squared. We work out the integral in step 3, and then we plug the numbers in, which we did right here in step 4, and we get 10 2/3 square units. Okay, and that's basically our simplest example we can get there. Okay, let's do another example of something similar. Okay, let me come up with one here. Let's do one. Let's do a second one. Let's see if we can do it. Okay, so let's do this on the second page. And try to work it with me. If you want to pause and try it on your own, if you're working on your own and there's nobody in your class, you just want to do that, that's fine. And if you just want to follow along with me, that's fine too. Let's say that we have example 2. Let's say we have y equals x plus 4. That's a line. And y equals x squared minus 2x. Okay. Find the area between the two curves. Okay, so step 1 is to sketch this out and kind of get an idea what it looks like. Okay, so this integral is not going to be at 0, 0. Actually, we probably don't even need the... Well, actually, we do. We should... we'll do it this way. Oh, yes. Sketch this out. So, okay, this quadratic here, if we factor out an x there, it's going to be 0 and 2. So we could just plug some numbers in. Like if we want to know what the lowest mark is going to be, we're not exactly sure, but we know it opens up. The vertex here, if we wrote it, we could complete the square and write the vertex, but we don't have to be exact on this, but we do have to know whether it's the upper or lower limit, right? Is it a curve and then the line underneath and then we want the limit, or is it the curve and then the line over top? That's what we have to know. So there's a couple ways we can do that. Okay, so just plugging some numbers in. If we put a 0 in there, it does cross 0.00. Right? 0 in for x gives you 0. If you put in a 1 in for x, you get 1 minus 2. You get a negative 1. Right? So you know it's going to go down here. Okay? If you put a 2 in for x, you get 4 minus 4, which is 0. So you know it's going to kind of go like this. just by using substitution. And we kind of figured out what that would be right there. That would be 1 and negative 1 is kind of the vertex point. Okay, and then if we do y equals 4x, so if we kind of look at that one, if we put in a 0 in there, that's going to be 4. So it's going to be up here. If we put in a negative 4, that's going to be 0. Y is going to be 0. So this is going to be, so it's going to kind of go like this. This is negative 4, 0. And this up here is 0, 4. Okay, and we don't know, so we kind of get an idea of what the two lines are. This is y equals x plus 4. So we know that the line is the upper limit. Okay, we could see that. So now we got to figure out what is b and what is a. Okay, so solve for b and a. Okay, so the first step here would be to go, okay, x plus 4 equals x squared minus 2. Bring everything over to this side. So let's go 0 equals, okay, so we got to subtract an x, so this would be x squared, subtract an x from here, subtract an x from here, would give you negative 3x, subtract a 4, subtract a 4. So there is our equation. We can factor that out nicely. Okay, so two numbers that multiply to negative 4 and add to negative 3. So negative 4 and positive 1. So our two intersection points then are x equals 4 or x equals negative 1. So that means that this is negative 1 and this is positive 4. Okay, so our leftmost one is negative 1 and our rightmost one is 4. So now we have to decide which one goes on top. Well, the line is on top. So step 2 is to integrate from our limits of 4 to negative 1 of the top limit line, which is x plus 4 minus x squared minus 2x dx. So you can see why I do that, because we're going to have to do a little simplification in there first, right? And it should be very similar to what we get, but you got to be careful here. Got to be careful with signs. Okay, and I do too. That's going to give us the area, by the way. Okay, so let's go ahead and do this. Okay, simplifying in here. It's a negative 1. Okay, so I'm going to get negative x squared, right? And this is going to be a plus 2x plus 3x. And I'm going to get plus 4 because there's no number to subtract there. Dx. Okay, now there's two limits here, so we're going to have to do two of them. There's a 4 and a negative 1. So now we have to integrate. So this is going to be negative 2. What am I doing? 2. Negative. Let's do that properly here. Got to do the integration. So negative 1 times x cubed over 3 plus, okay, so we got to do that. Plus 3 times x squared over 2. Okay, so far so good. Plus 4x minus the two constants. Okay, now we're going to go from 4 to -1. So we got to plug in the 4 first, figure out what it is, and subtract the 1 plugged in. So let's go ahead and plug in the 4 first. So this is -4 cubed. This whole thing is negative over 3 plus 3 times 4 squared over 2 plus 4 times 4 minus, in brackets, the whole thing again, but with a -1 in front. A -1 cubed over 3. Okay, and then we got to put in this one, plus 3 times -1 squared over 2 plus 4 times -1. And all kinds of weird stuff there. Okay, so now we got to do some calculation here. 4 times 4 times 4 is 64 over 3, so this would be -64 over 3. Okay, this will be a plus. 3 times 16 over 2, that's 24. And this is 16. Okay, over here in the other one, this is going to be negative. Okay, we're just going to leave that out front. This is minus out front. And we're going to have a minus. Okay, so this is going to be -1 times -1 times -1. That'll be minus a -1/3. Okay, because we got the negative out front, plus we're putting a -1 up there. So that kind of gets it all weirded out a little bit, right? That's -1/3, and there's still that negative out front because we're working out this whole thing. And we're also having the negative in here as well. Okay, so don't get confused by that. So we have the bracket here for subtracting this whole thing, and then the negative here for this. And then when that negative gets reduced down, we have that negative in front. So it's a bunch of piles of negatives. Plus 3 times 1 over 2. Okay. Minus 4. Okay, let's just double check my negatives here. So this would be -1, and then I'd have to have a negative in front of it for that. So this would be -1. So this should actually be -1/3, and then when I do the negative here, this is going to become a positive. So this is going to become, as we move down, -64 over 3. This is going to be plus 40. Minus, okay, so this would be 1/3 plus 3/2 minus 4. Okay, I'm a little worried on my negatives there. Hopefully I didn't make a negative mistake. 3 negatives there give us a negative, then take the negative of that gives us a positive there, and then we're going to take another negative eventually. So hopefully I didn't make any mistakes there. If I did, sorry. Okay, so then we have to add them together. So this is going to be -64 over 3 plus 120 over 3, because we multiply that by 3. And then subtract, okay, 1/3, we're going to have to do everything to sixths. So this will be 2/6. This will be 9/6. And this would be 6 times 4 is 24/6. Okay. When we do all those, okay, you're like, can I use decimals, Mr. E? Yeah, you can use decimals, no problem, if you want to. Okay, 64 from 120 gives us, what is that? 60 minus 4, 56 thirds. Okay, and then minus, okay, we got 11 subtract 24. Okay, so 11 subtract 24 is good, sixths, by the way. So that would be give us 13 negative sixths. Okay, so then this would give us 56 over 3 plus 13 over 6, because that's two negatives there. And then we'd have to double this so that to get sixths. So we'd have 112 sixths plus 13 sixths. 25 over 6 square units. Okay, sorry if I did make it a minus there in there, I might have. I hope I didn't. You have to be careful with that. That's the tricky part of that. So that's the first part of our, just showing you some basic ones without any substitution methods, without any methods of, without any bounding limits or anything like that. You can have, I've got another example with two quadratics that we can try, but we're already pushing close to 32 minutes here. So what I'm going to do is tomorrow I'll do a couple more examples, maybe two quadratic example, and then doing one without intersection points, and then we'll do the hand-in part of, the practice part, and then the hand-in will come after that. Quiz, and then we're done. Okay, so we'll stop there, and we'll put that up next day.